Hello, everyone. Welcome back. I'm Steve.
And I'm Scott.
And together we are Backyard Musings, broadcasting live from Apple Valley, California.
Science and Technology Channel.
Yes, sir. The key to this climate modeling gaffe that they found lies in Arctic clouds during winter, as climate models tend to underestimate how much liquid they contain and how much heat they retain. Duh, who can predict cloud coverage? I mean, the meteorologists, they don't know it. This leads to inaccurate predictions of future warming. The Arctic is one of the coldest regions on Earth, but in recent decades, it has been warming rapidly, 3 to 4 times faster than the global average. Yet current climate models have struggled to explain this accelerated warming. The findings were published on April 29, 2025 in Ocean, Land, Atmosphere Research. Would you like to know more?
Now, researchers from Kyushu University graduate student Momoka Nakanishi of the Interdisciplinary Graduate School of Engineering Sciences and her advisor, Associate Professor Takuro Michibata of the Research Institute of Applied Mechanics, have suggested that clouds may be the key factor. Their findings were published in the journal Ocean, Land, Atmosphere Research.
The most common clouds in the Arctic are mixed phase clouds, which contain both ice crystals and supercooled liquid water droplets. During the Arctic summer, when sunlight is constant, these clouds reflect sunlight back into space like a parasol, helping to cool the region. In contrast, during the long, dark Arctic winter, when there's no sunlight to reflect, the same clouds behave like a blanket, trapping heat radiated from the Earth's surface and sending it back down to the ground. That's fascinating.
Yeah,
makes sense.
Yeah, this is a quote. However, how well these mixed phase clouds trap heat depends on the ratio of ice to liquid, explains Nakanishi. Go on with the quote. The more liquid water the clouds contain, the better they are at trapping heat. Many climate models have a large bias in representing this ratio, causing incorrect predictions.
Yeah, like I was talking with Jeff before the segment. Or maybe it was on the segment. You could manipulate that data to say whatever you want it to say.
Jeff?
You know? Scott. I don't know why I said Jeff.
It's okay.
Man, I'm getting old.
We were talking about Jeff before we went on.
those cells are starting to degenerate. In this study, Nakanishi and Michibata analyzed 30 climate models and compared them to satellite observations of clouds in the Arctic during winter over the last decade. They found that 21... It's fascinating that they capture these photos and they store them historically and then they look at them. They found that 21 of the 30 models significantly overestimated the fraction of ice to liquid in wintertime Arctic clouds.
Quote again, these ice-dominant models are not properly accounting for the present-day warming potential of the clouds during the winter, says Nakanishi. That's why they cannot account for the rapid warming we are currently seeing, unquote.
However, every cloud has a silver lining, pun intended. While climate models are underestimating the rate of global warming in the present day, they're overestimating the rate of global warming in the future.
The errors in future projections are due to a process called cloud emissivity feedback. In a nutshell, as the Arctic warms, clouds shift from containing mostly ice to more liquid, which increases their ability to trap heat, further warming the Arctic and creating a positive feedback loop.
Yeah, I guess as we progress in the ice age too, where we are in position with the sun, that can just get drastically worse or drastically better.
So are we coming out of the ice age or are we going into the ice age?
Coming out.
Coming out.
Yeah,
okay.
Yeah. But importantly, this feedback loop has a time limit. Once clouds become so rich and you know what?
I just want to make sure if I'm packing my winter clothes too soon. So
we should go back to that segment that we did and rebroadcast it about, where the position of the sun, how it matters, where we are, where the sun is, in our, elliptical thing. We should redo that. Okay. But importantly, this feedback loop has a time limit. Once clouds become so rich in liquid that they behave like black bodies, fully absorbing and re-emitting heat, further warming has less effect.
However, because many climate models underestimate how much liquid is already present in today's clouds, they assume a longer shift still lies ahead. As a result, they overestimate how much extra heat trapping will occur in the future and predict the feedback effect will last longer than reality suggests. Okay.
These models, computer models. Moving forward, the study's findings could be used to refine climate models so that they provide a more accurate representation of the ice to liquid ratio within clouds and better predictions of current and future rates of Arctic warming.
Since the Arctic's climate also plays a key role in shaping weather patterns further south, these findings could also lead to a more accurate forecasts of extreme weather in mid-latitude regions.
Quote, the biggest uncertainty in our forecast is due to clouds, concludes Michibata. He continues, fixing these models is essential not just for the Arctic, but for understanding its impact on weather and climate change across the globe. So this ties in nicely with, the ice age. These climate zealots I think they're misinterpreting the data to make it fit to what they want.
So in my simplified thinking, do we know how much longer this ice age is going to last? No idea.
These
Another
ice are
season?
like 14,000, 15,000 years, Winter is coming. Isn't that what they say? From Game of Thrones.
All right. Don't put away your down jacket just yet.
Yeah.
Okay.
All right, folks. Thanks for joining us.
Take care, everyone. Thanks.